What I hope to do in this video is get some practice simplifying some fairly hairy exponential expressions. So let's get started. Let's say that I have the expression 10 times 9 to the t over 2 plus 2 power times 5 to the 3t. And what I want to do is simplify this as much as possible and preferably get it in the form of a times b to the t. And like always, I encourage you to pause this video and see if you can do this on your own using exponent properties, your knowledge, your deep knowledge of exponent properties. All right, so let's work through this together. And it's really just about breaking the pieces up. So 10, I'll just leave that as 10 for now. There doesn't seem to be much to do there. But there's all sorts of interesting things going on here. So 9 to the t over 2 plus 2, so this right over here, I could break this up using the fact that, and I'll just write the properties over here. If I have 9 to the a plus b power, this is the same thing as 9 to the a times 9 to the b power. And over here, I have 9 to the t over 2 plus 2. So I could rewrite this as 9 to the t over 2 power times 9 squared. Times 9 squared. All right. Now let's move over to 5 to the 3t. Well, if I have a to the bc, so you could view this as 5 to the 3 times t. This is the same thing as a to the b, and then that to the c power. So I could write this as, this is going to be the same thing as 5 to the third, and then that to the t power. And the whole reason I did that is, well, this is just going to be a number, and then I'm going to have some number to the t power. I want to get as many things just raised to the t power as possible, just to see if I can simplify this thing. So this character right over here is going to be 81. 9 squared is 81. 5 to the third power, let's see, 25 times 5, that's 125. So we're making good progress. And so the only thing we really have to simplify at this point is 9 to the t over 2. And actually, let me do that over here. 9 to the t over 2. Well, that's the same thing. That's the same thing as 9 to the 1/2 times t. And by this property right over here, that's the same thing as 9 to the 1, 9 to the 1/2 times, or 9 to the 1/2, and then that to the t power. So what's 9 to the 1/2? Well, that's 3. So this is going to be equal to 3 to the t power. So this right over here is 3 to the t power. So now this is getting interesting. So I have the 10 out front. I have the 10 out front times 3 to the t. 3 to the t. Actually, let me write the 81 first. 10 times 81 times 3 to the t. So all I did is I just swapped the order that I'm multiplying. Times 125 to the t. Times 125 to the t power. Now, the 10 times 81, I could just multiply that out. That's going to be 810. And then what's 3 to the t times 125 to the t? Well, this is another exponent property at play here. Because if I have a times b to the t power, that's a to the t times b to the t. Or another way to think about it, if I have a to the t times b to the t, that's the same thing as a times b to the t power. And so over here I have 3 to the t times 125 to the t. So it's going to be the same thing as 3 times 125 to the t power. So this part of it, right over here, I could rewrite it as 3 times 125, and I'm going to raise that whole thing to the t power. So I'm in the home stretch. This is going to be 810 times 3 times 125 is 375 times 375 to the t power. And that's about as simplified as we can get. And we did indeed write it in the form that we hope to write it in, that a times b to the t, where if we actually match this form right over here, this right over here would be our a, and then our b would be the 375 the b would be the 375. So anyway, I know it looked a little bit daunting when you first saw it, but if you just keep saying, okay, let's just keep applying some exponent properties here. Let's see if I can get multiple things to the t power and keep breaking it down using these properties, you see that in not too many steps you get to something that's a lot less hairy.